for a series circuit, one of the biggest things we know is that the current moving through the circuit is going to remain the same. It's a constant current. So once we find it once, it is always going to be that same value. Okay? We know the total voltage comes from the battery, right? But we know there's going to be a voltage drop over all the resistors, so it turns out that the total voltage is going to be the sum of each of the voltage drops over the resistors. And then for resistance, we know the total resistance is going to be the sum of the individual resistance. Okay, so it's an easy way to find the total resistance. So looking at example 1, I have a 12-volt battery, and I have 3 resistors, 1 ohm, 2 ohms, and 2 ohms. And what we're trying to do is we want to solve for the total current, and we want to find the potential difference at each resistor. Okay, now if I'm looking for the total current, what I do know is I know that the total potential, all right, so I know that my total voltage, which would be my battery, has to equal the total current, which remains constant, times the total resistance, otherwise known as the equivalent resistance. Now, if I'm looking for current, then obviously I'm going to say I equals V over R. All right, but what is V total? It's 12 volts. What about R total? How do we get the total resistance? We just add them up. So for R total, R total is going to be just the sum. So we get RT equals 1 ohm plus 2 ohms plus 2 ohms, and that's going to be 5 ohms. So that's my total resistance for the circuit. So I come over here, I have 12 volts divided by 5 ohms, and my I total equals 2.4. What are the units for current? Amps. So 2.4 amps. So now I have my total current. But then we are trying to find the potential difference at each resistor. So we want to figure out what that drop in voltage is at each resistor. So what we also know, again, we still know that V equals IR. Now I did V total equals I total R total, but V1 equals I total times resistor 1. Okay? Why does it equal I total? Because in a series, so in series, the current is constant. All right, so the total current is going to be the same current at each resistor. So if I'm looking for the total potential difference, so I'm trying to find, we can go ahead, if it's a potential difference, put a delta there. So delta V1 has to equal 2.4 amps times the value of resistor 1, which is 1 ohm. And therefore, that's going to equal 2.4, what are the units for voltage? Volts. Okay. Now, what do we know about the voltage drop at R2 and R3? It's going to be the same because they have the same resistance and they're in series. So the voltage drop has to be the same. So I know that delta V2 equals delta V3, which equals 2.4 amps times 2 ohms, which equals 4.8 volts. All right, so here I kind of have my work everywhere about. I'm putting together these equations. It is much easier if you consider using a table to organize your work. So number 2 is a very similar problem. The difference is there's a table set up. So I've labeled all of my resistors, and I have a total column here, and we have a 15-volt battery. Now, because we have that 15-volt battery, what can I already write in my table? we know that the voltage is going to be total 15 volts. Now at each resistor, what's going to happen? It's going to differ depending on the value of the resistance. Okay, next, I know my resistors, so I'm just going to write them in order here. I'm going to put 12, 6, 7. I'm going to put volts here, amps here, and ohms here, so I don't have to keep rewriting it. How do I get the total resistance in a series circuit? So this is going to be the sum. So what's 12 plus 6 plus 7? What is it? 25 ohms. Okay, so that's my total. And then here I get my total from the battery. Okay, what do I know about the current value? It's going to be constant. Okay, I know this is going to be constant. I also know then that I is going to be V total divided by R total, and so that is 0.6. Okay, so this is going to be 15 volts divided by 25 ohms, which is 0.6 amps, which means this is 0.6, 0.6, 0.6. How do I fill in the rest of the table? We know that V equals IR, so that is what we're doing over here, right? V equals IR. What's 0.6 times 12? 7.2. 0.6 times 6 is 3.6, and then 7 times 0.6 is 4.2. So the table, do you guys see how the table makes it very easy to organize your work? You guys need to work on remembering these ideas that go with the series circuit.